Going to see doubly linked list. So today's topic is doubly linked list. Okay. So before going to doubly linked list, in previous class, what we saw? Previous class, we saw what is meant by linked list and what are the types of linked list. What is the need to go for linked list? What is the application of linked list? And we saw certain questions. Okay. Based on singly linked list, we saw the basic part, right? So next type today, we are going to discuss about doubly linked list, and today we will discuss with the questions based on the linked list. Gate questions we will discuss. Okay. So first, what is meant by doubly linked list? In singular linked list, what we saw now, all the nodes will be connected and each node will be having the two field. One is what the data field and another one is what the address field, right? So here also in doubly linked list, similar thing like your singly linked list, but here each node will be having a three field. In singly linked list, you will be having two field, but here you will be having three field. So one is a previous node address I need to store. For that I'll be having one field, that is prev field. Another, to store the data, I'll be having the data field, and to store the next field address, I'll be having the next field. So totally I'll be having three field in my single node. So comparing to singly linked list, doubly linked list requires handling of more pointer. So normally pointer will be storing the address of the another node. To store the address, I'll be going for the pointer concept, right? So handling of more pointer but less information is required, as one can use the previous link to observe the preceding element. So it is also has a dynamic size which can be determined only at the runtime. Okay. So linked list is normally is what? It's of dynamic size memory. Okay, not static size, right? So dynamic size memory. So here also you'll be having a where the dynamic size which can be determined only at the runtime. Okay. So this is the diagrammatic representation of this doubly linked list. So here each node I'm having three field. So one previous field is null because previously I don't have any node. I'm just so entering like null. And this is a starting or header pointer, so which I'm just mentioning with L. And next field I'm having the value like 1000. So here this 1000 is nothing but the address of this node. So for each node I'll be having the address. So here this L which contains the address of this 10 value node. So 1000 is stored here in this address. So next node I'm having the previous node. What is the previous node? This node address is 900. So only I'm having the previous field as 900. Next node address is what? 2000. So here the next field are having the address as what? 2000. Okay. And here the value I'm just entering like what? 10. So similar way, here another node. So another node which is having like what? Previous node address is 1000. So I'm having here 1000. Next node address, I don't have the next node where I'm having the, I don't have any address. So I'm just placing like what? Null over here. I'm just placing the value like 20 over here. So this is how the node representation we having in a doubly linked list. So what are the operations I can do under doubly linked list? Means like your singly linked list. Here also I can do insertion, deletion, searching the element, or displaying the element. All those things I can do in this doubly linked list operation. So how I can declare? How I can declare the doubly linked list? Like your singly linked list, similar way I can declare for doubly linked list, but the single sentence what I need to include means here I am using two pointer field. So position next alone I'll be using in singly linked list, but in doubly linked list I need to use position previous, that is PREV, and position next. So two field I need to use. Okay, under this structure node. Okay. So here each node will contain what? A data field, and another one is what? Previous field to store the previous address, and next field to store the next node address. Okay. So totally I'll be having three field under my node structure. So what is the program to create the node in a doubly linked list concept? Similar thing like your singly linked list. I'm using the create function. Inside that, I'm just declaring with the variable I n. I'm using this I for a for loop. Okay, for loop, using the for loop one by one. I need to move the elements. So for that, I'm using that I n for number of elements. For that, I'm using this n. Okay. So initially, I'm just giving L equal to null in the sense no element it is representing. Okay. So no address is there. So L equal to null, which represents that. So first I need to create a new node. So that is possible using my malloc memory allocation. I'm just allocating the memory. So new node equal to struct node asterisk malloc of size of struct node. I'm creating a new node. Okay. So where I'm just giving the size of struct node. So size of struct node means under structure I'm having 3. The int data means it is allocating, if it is 64-bit means 4 bytes. And for previous and next, as it is pointer variable, it will be having 4. So totally 12 bytes it will be allocated for new node. So next line print of enter the number of nodes to be inserted. So I'm just entering with the number of nodes, 5, 10 or 11, whatever the case. I'm just entering with the number of elements. So n. Next, enter the data. Okay, I'm just entering the data. So first, I'm just entering with that data 10 means that will be stored in the address of new node of data. So next is what? New node of next equal to null. Address field, I'm just initializing like null. And previous field address, I'm just initializing like null. Next, L equal to new node means our starting node. Next, P equal to L in the sense what? That is starting from the first. So it is representing that starting pointer. Next, for equal to for of I equal to 2. So starting from the second node, I'm just doing the operation. Okay. So I less than equal to n I plus plus. So again, I'm creating the new node. Okay, using malloc. Then one by one, I'm just getting the data 10, 20, 30, 40 like that. And that will be stored in the address of new node of data. Next, I'm just initially new node, initially the first node where previous node will not be there and next node will not be there. So obviously previous field and next field of this particular node will be what? Will be null. Okay, so that is only here. New node of next equal to null and then new node of previous equal to null. So next I need to move to the pointing to the new node. Okay, P of next equal to new node means I'm just pointing to that new node. And then new node of previous equal to P. Because of this, I'm just connecting one node with the another. Okay. So next P equal to new node. Okay. So this is about the creation of the nodes in the doubly linked list. So like this, if I'm doing means doubly linked list node will be what? Created like this. Okay. So if I here I have inserted what? Two elements 10 and 20. So two node I have inserted. So using this create function, I'm just creating this node. Okay. So what for this particular program, the output will be like this. Okay, so this create function is over. So next is what? Insert. Okay, so insert function. So next is what? Insert function. If I want to insert a element in a particular list, if I want to insert a element in a particular list, in the sense int pose comma I. Okay, so that is a variable pose I of type int. Next, I'm just creating a new node. Okay, where I'm just allocating the memory size. Okay, using that, I'm just creating a new node. Next, using the printf, I'm just getting the data, inserting the data one by one. Okay, so what element I need to insert, that element I'm going to enter, and that will be stored in the address of new node of info. So next, I'm just checking whether that current header is null. Okay, so head equal to null. I'm just checking. If it is null, means I'm just initializing that new node to this head, and the head of next equal to null, and head of previous equal to null. If that head is not null, means I'm going to enter the position where the data to be inserted. Okay, no element is there, means I can insert as a first element. If the element is there, means I need to know the position in which I need to insert the element. Okay, so that position I'm just getting. Okay, for that printf, enter the position where the data is to be inserted, means that position 1 or 2 or 3 or that position I'm just getting. Next, I'm just checking whether that position equal to 1. First position, Anna, I'm just checking. Whether it is first position, means I'm just having this header pointer that will be initialized to this new node of next. And new node of previous contains nothing, because this will be the first element. Okay, so next head of previous equal to new node. So next head equal to new node. Else means ptr equal to head, where I'll be checking using this for loop I equal to 1, where the I value will be 1, and then it will be checking the condition 1 less than post minus 1, and at the same time it will be checking pointer of text not equal to null. If this true, means it is coming here. Here I'm just checking each node. So ptr equal to pt of next, and now moving next node. Okay, after that, I'm just initializing new node of Nextella. I'm just putting PTR of next, and PTR of Nextella, I'm just putting the new node. New node of previous, I'm just having the PTR. I will show this using the whiteboard. Okay, so how this happening, I will show in the whiteboard by sharing the whiteboard. I will tell that diagrammatical implementation. Okay, so here they have given. So this is like I want to display the elements in a list. So using the display function, I'm just doing. So I'm just checking whether that head equal to null, means no number of elements in a list. No element is present in a list. Else means I need to print all the elements in a stack. Okay, so for ptr equal to head, I need to check ptr not equal to null, and then it is coming here, and ptr of info means that corresponding data will be what? Printed by moving to the next point. So this is about what? Display part. So next is about delete. If I want to delete a particular element in a list, okay, so that I can do, where I need to check whether that starting node is equal to null. Like that, I need to check. If it is null, means I need to print the list is empty. Else means I need to enter the position of the data to be deleted. So that will be stored in the address of post. Next, I need to initialize temp equal to head. If the position is 1, means I need to delete the element temp of info. Then head will be what? Head equal to temp of next, and head of previous equal to null. And then I am just freeing the temp. Okay, else in the sense what happens? ptr equal to head, and for I equal to 1, I less than post minus 1, and then I'm just incrementing 1 by 1. So ptr equal to ptr of next node, it is just moving, and lastly we are deleting the particular element. After deleting, how we are deleting? By freeing the space using the free. So we are going to see the questions based on the complexity analysis which we are using in this algorithm. That is based on this linked list we are using this. So an essential aspect to data structure is what our algorithm. So data structures are normally implemented using the algorithm. So algorithm is nothing but what is a procedure that you can write as a C function or a program what it needs to do, whatever the language. So algorithm state explicitly how the data will be what implemented or manipulated. Okay. So algorithm efficiency. Okay. So some algorithm are more efficient than others. So we would prefer to choose an efficient algorithm. So we need to choose an efficient algorithm. So it would be nice to have metrics for comparing the algorithm efficiency. Okay. So algorithm efficiency in the sense it is talking about the complexity of the algorithm. So complexity of an algorithm is nothing but a function describing the efficiency in terms of amount of data the algorithm must process. So if it is telling the amount of data the algorithm must process, that is about the complexity of an algorithm. Okay. So usually okay, so usually we having two things. One is what time complexity, and another one is space complexity. So time complexity is nothing but what describing the amount. Okay, describing the amount of time an algorithm takes in terms of an amount of impact to that particular algorithm. How much time it is taking. Space in the sense memory, it is talking about the memory space. How much extra memory space it is needed. Okay, not counting the memory needed, but to store the input itself. Okay, so for example, we might say this algorithm takes n square times, where n is the number of items in the input. Or we might say the algorithm takes constant extra space because the amount of extra memory needed doesn't vary with the number of item processed. Okay, so this is about what time complexity and space complexity. So time now, how much time it is taking for processing the result. Okay, to giving the result. Space in the sense how much memory it is taking for storage purpose. Okay, so this is about the time and space complexity which will be coming up in the efficiency of an algorithm. So now we will discuss with some gate questions. Okay, so 2020 paper they have asked. So what is the worst case time complexity of inserting n elements into an empty linked list if an linked list needs to be maintained in sorted order? So what is the worst case time complexity? Here, this is a MCQ question which is asked in the gate, where the answer where we contains more than one answer we can pick for this particular question. So here, what is the question? If I want to insert n elements, okay, where the linked list is empty, no element is present. Okay, I want to insert the element. Okay, so worst case, what will be the time complexity? We having worst case, best case, average case like this we having. So worst case, how much time it will takes if the linked list needs to be maintained in a sorted order. Okay, sorted order means what? It will be in ascending or descending order. Okay, so it will be there in a sorted order. Okay, so here big O of n square and then big O of n log n. Okay, so big O of n square and big O of n log n. N square in the sense what? How much time? If I'm just entering with two elements, so to one element means one data. Two elements means two times it will be taking the time complexity. So big of n square and big of n log n, or the first case time complexity for inserting the n elements into one empty linked list if an linked list needs to be maintained in a sorted order. Okay. So next gate question we are going to discuss in 2016 question paper, which is a single correct answer I need to give. So what is the question over here means I'm having n items. I'm storing that n items in a sorted doubly linked list way that it contains three field, previous data field and then the next field. Okay, so for a deletion operation, what I'm doing means a pointer is provided to a record to be deleted. So for a decrease key operation, a pointer is provided to a record on which the operation is to be performed. So an algorithm performs the following operation on a list in this order. First biko of n, next delete, next biko of log of n insert, and next biko of log n, and biko of n decrease key. So what is the time complexity for all these operations put together? Okay, so if they're asking the time complexity based on this linked list, just give biko of n square. Okay, so that will be the time complexity for doing all these operations put together. Where n items I'm just stored in a sorted doubly linked list. Okay, so for a delete operation, a pointer is provided to a record to be deleted. So here for this question, the answer is biko of n square. So next question is about which is asked in 2004 gate question. So here let P be a singly linked list. Let Q be a pointer to an intermediate node X in a list. Then what is the worst case time complexity of a best known algorithm to delete a node X from the list? So here biko of 1. Okay, so let P be a singly linked list and Q be a pointer to an intermediate node X in a list. So then what is the worst case time complexity? Okay, what is the worst case time complexity of the best known algorithm? Best known algorithm to delete a node X from a list means its worst case will be what? Biko of 1. So next question which is asked in 2002, it is a single correct answer MCQ question. So here they have discussed with in the worst case, how many number of comparison needed to search a singly linked list of length n for a given element. Okay, so how many number of comparison I need to have to search a singly linked list of length n for a given element. So totally how many element n? So what will be how many number of comparison then it will be there? Then n. So that is in the first case. So answer is n. Okay, so this is a gate question which is asked in 2018. So where a queue is implemented using a non-circular singly linked list. The queue has a head pointer and a tail pointer as shown in the figure. Let n denote the number of nodes in a queue. Let NQ be implemented by inserting a new node at the head and DQ be implemented by deletion of a node from a tail. So which one of the following is the time complexity of the most time efficient implementation of NQ and DQ respectively for this data structure? Okay, so Q we are implementing using non-circular singly linked list. So Q has a head pointer and a tail pointer. Let n denotes the number of nodes in a queue. So let nqb means what? We are inserting the element new node at a head. Dq means what? We are deleting the node from a tail. Okay, so here what is the question? Which one of the following is a time complexity of the most time efficient implementation of our NQ? NQ means insertion, DQ means deletion. Okay, so like this they are asking. Okay, we are implementing this queue using this linked list, right? So here the question is, which one of the following is a time complexity of the most time efficient implementation of NQ and DQ respectively for this data structure? So first one will contains a time efficient implementation of NQ, and second one will contain the time efficient implementation of DQ. Okay, so for NQ it will be what, BQ of 1, and for DQ it will be what, BQ of n. So inserting means one element only I'll be inserting at a time, right? So it will be of BQ of 1 complexity. And DQ means what, I can delete n element is there means I can delete n element at a time. So what will be DQ? BQ of n. Okay, what will be the time efficient implementation for DQ? It will be BQ of n. Okay, next, the following C functions takes a simply linked list as input argument. Okay, and then it modifies the list by moving the last element to the front of the list, and it returns a modified list. So some part of the code is left blank. Okay, so this question which is asked in 2010 gate question paper as a MCQ question. So here they have given with the C function which takes a linked list as an input argument, and it modifies the list by moving the last element. Okay, by moving the last element to the front of the list. Okay, last element I'm just moving to the front, and what will be the modified list? I need to return that modified list. Here some part of the code is left blank, so I need to tell that part of code which is left blank. So see here, using the structure node, I have just declared with the two thing. One is the value which is of type int, and next I'm just declaring with the address field. Next field which is of type struct node asterisk, and here I'm just creating with a structure variable node. So here node, the function move to front, where I'm just passing the pointer argument. Okay, node asterisk head. So inside this, I'm having two variables, p, q, two pointer variable. I'm just declaring of type node. Okay, here I'm just checking if head equal to null, or a head of next equal to null. Okay, if this condition satisfies means I'm just initializing null to q, or else I'm just initializing head to p. Okay, next using this while, okay, using this looping, I'm just checking whether p of next not equal to null. If this is the case means I'm just declaring q equal to p, and then p of next node. Okay, I'm just initializing to p. So p equal to p of next. Next, finally, I'm just returning the head. Okay. So here in this program, I need to choose a correct alternative to replace this blank line. Okay. So, okay. So here, what are the choices they have given? Q equal to null, Q of next equal to head equal to P as a first option. Second option, Q of next equal to null, head equal to P, P of next equal to head. My third option, head equal to P, P of next equal to Q, and Q of next equal to null. Next, my fourth option, Q of next equal to null, P of next equal to head, and head equal to P. Okay, so I need to choose the correct one to replace my blank line. So Okay. So here some part of coding is what left blank. Okay. So here for this one over here, they have given with this coding which part it needs to have. So Q of next equal to null, and then P of next equal to head. Okay. Q of next this line. Q of next equal to null and P of next equal to head, and the head I am just initializing as a starting pointer. Okay, so this will be a correct option to replace this blank line present over here. Okay, so next is about the gate question which is asked in 2008. The following C function takes a single linked list of integer as a parameter and it rearranges the elements of a list. Okay, so the function is called with the list containing the integers 1, 2, 3, 4, 5, 6, 7 in a given order. So what will be the content of the list after the function completes execution? Okay, so following C function and takes a singly linked list of integer as a parameter. Okay, 1, 2, 3 like that. And we are arranging the elements, rearranging the element. So for example, the function, okay, is called with the list of elements which is having the integer 1, 2, 3, 4, 5, 6, 7 in a given order. Okay. Then what will be the content of the list after the function completes execution? Okay. So if this is the list of integer I'm giving means after the execution of this particular function, what will be my output? Okay. So that is the question they have asked. So here it is arranged in a sorted order. So first struct node int val. I'm just declaring with the two field. One is the data field which is having the variable like value which is of type int. Next is the address field, that is the next field which is of type struct node. Okay. So next I'm just calling this function, that is our rearrange function, where I'm just passing the list as an argument. Okay. So struct node asterisk p asterisk q in the sense two pointer variable I'm just declaring of type struct node. Next I'm just declaring with a temp of type int. Next I'm just checking if not list or not list of next means I'm just returning. Okay, what I'm just returning over here and then initializing p equal to list and q equal to list of next. Here I'm just checking with the condition while of q temp equal to p of value and p of value equal to q of value and then q of value equal to temp. Okay, so like that I'm just rearrange. So if I'm rearranging, normally while of q is the list of element. So temp equal to p of value is the first value. Okay, then what will be the case if we are executing this? So this is the question. Like this also they'll be asking. So for this, what I need to do? I need to iterate this particular function. Okay, so if I'm just iterating this particular function, what value for each iteration, what are the values coming? And that value I need to put and I'll be getting the result like this. 2, 1, 4, 3, 6, 5, 7. Okay. So each iteration you need to what evaluate and you need to produce the result. Then one will be getting this output. So next is about the question. What does the following function do for a given linked list with first node as head? Okay, what does the following function do for a given linked list with first node as head? Means first I'm just having the function fun one where I'm just passing the argument head, where if that head starting node is equal to null means I'm just returning the entire list of elements, or else I'm just calling the function fun of one where head of next I'm just moving to the next node. Okay, next I'm just printing with the data head of data. Okay. So what are the option means? If I'm just executing this function, okay, what will be the output? One by one, it will be checking, it will be displaying with the data, right? Element. So it will print all the nodes of the linked list. It will print all the nodes of the linked list in reverse order. Or else C option print alternate nodes of linked list. Or D option prints alternate nodes in reverse order. So what will be the option? They have given with the answer as print all nodes of linked list in reverse order. Okay. So in reverse order, in the sense what, first I'm just checking first head one the not equal to null. No? It is just returning no element is there. Or else it is just calling head of next function. So head of next function, now what happens? Again it is moving here. Again it will be checking null done. No, it will not be null. Some value will be there. Right. So what happens? Again it will be calling the next function. Again it will be in one case what happens na, that head will be coming to the last node where it contains nothing. So it will be returning the sense what it will be returning. So one by one, this should be outside. One by one in the sense it will be in the last area. It will be going in the reverse manner. Again, so if I'm having the value 1, 2, 3, 4, now it will be printing 4. Next to 3, next to 2, next to 1. So in the reverse order, it will be printing one by one. So it will print all the nodes of the linked list in a reverse order. Okay, so function 1 prints a given linked list in reverse manner. For linked list 1, 2, 3, 4, 5, my function 1 prints 5, 4, 3, 2, 1. Okay, so you can execute this program online also. Okay, so while you are executing this program online, you'll be getting the output. You can edit the program also and you can see the changes what happens. Okay. So next question, what are the time complexities of finding eighth element from beginning and eighth element from end in a singly linked list? Let n be the number of nodes in linked list. You may assume that n greater than 8. Then what will be the time complexity for finding the eighth element? So n greater than 8 means what? Number of element is greater than 8. So 8 or 9 like that. Okay. What the question? What is the time complexity for finding eighth element from the beginning or eighth element from the end? So from the beginning, from the end. From the beginning in the sense what now? The time complexity will be what now? Big O of n, big O of 1. Okay. From the end, eighth element from end, na, it will be what? The last element. So big O of 1. Okay. So option is A. Answer is option A. So finding eighth element from the beginning, it requires what? Na? 8 nodes to be traversed, which takes a constant time, same time only. One by one, it will be taking. So, but finding eighth from end requires what? Na? It requires the complete list to be traversed. It requires a complete list to be traversed. Okay, so it takes what? Pick of n time for that. So next, consider the following function that takes reverse to reference to head of a doubly linked list as parameter. Assume that the node of doubly linked list has previous pointer as prev and next pointer as next. That is next previous prev we are keeping, and for next field I'm just keeping as next next. Okay, so this is a function I'm just having that takes a reference to the head of the doubly linked list as a parameter. Okay, so here the function void function I'm just giving struct node asterisk asterisk head ref. Okay, so where I'm just initializing null to temp and head ref to current. So here I'm just checking while current not equal to null. It should not be equal to null value. If this is a case means current of previous, I'm just initializing in temp. Then current of previous equal to what? Na current of next. Then current of next equal to what? Na our temporary value. Like that, I'm just placing that will be what link. Okay. So if temp not equal to null means I'm just initializing temp of previous to a head ref. So assume that reference of head of following doubly linked list is passed to above function. 1, 2, 3, 4, 5. I'm just passed. What should be the modified linked list after this function call? Okay, what is the modified linked list after this function call? So here the option A is 214365 and then option B is 543216 and option C is 654321 and option D is 654312. So here the answer is what? C. 654321. The given function reverses the given doubly linked list. Okay, if I'm passing 1, 2, 3, 4, 5 means what happens? It will be coming here. In this part, it will be coming here. 1, 2, 3, 4, 5. Next, again, struct node temp equal to null, no value will be there. Okay. Next, again, it is checking while current not equal to null. It is just checking. Okay, if it is not equal to null means it is just pointing temp equal to current of previous element. Okay, so starting from the previous element. So what happens? It will be reverse order. What element is there? 1, 2, 3, 4, 5. Now it will be printing 6, 5, 4, 3, 2, 1. So what is the option? It will be option. It chooses C. Okay. So next question is, which of the following sorting algorithm can be used to sort a random linked list with minimum time complexity? Okay. So which of the following sorting algorithm? We having many sorting algorithm, but which we can be used? Okay, to sort a random linked list with minimum time complexity. So they have given with the option insertion sort, quick sort, heap sort, merge sort. Okay, so here we chooses the option D, merge sort, because both merge sort and insertion sort can be used for the linked list actually. But what is my question? With minimum time complexity. Minimum time complexity means merge sort. Merge sort only we can easily divide the particular list of elements and it is searching with the first half. If it is there with the first half, it will not search with the second half. So time complexity, the time to take to sort the elements in a linked list, it is what very less. Okay, so only we are going for this minimum time complexity in the random linked list means we are going for this merge sort. Okay, so both merge sort and insertion sort can be used for linked list, but the slow random access performance of a linked list makes other algorithms such as quick sort perform poorly and others such as heap sort completely impossible. Since worst case time complexity of merge sort is big of n log n and the insertion sort is big of n power 2, merge sort is preferred. Okay, so for implementation of merge sort using linked list. Okay. Okay, so this we are covering with this doubly linked list. So similar way for circular linked list. Okay, but the linked list will be of what na in circular. It will be in what circular manner. It will be there. So this is about the linked list. So which one is preferred? Array is preferred or linked list is preferred means our linked list is preferred because dynamically it allocates a memory. So we can have any number of element during the execution time. So linked list is a preferred. So far in linked list, what are the topics we have covered? In previous session, we covered what is meant by linked list. And next we covered what are the types of linked list. Next we saw the application of linked list. Next, next we saw the questions based on this, and we saw the programs to execute the operations performed in the linked list, like insertion, deletion, um, display, all those operations, searching the particular element, all those operations we saw in the linked list, and we saw the programs also, right? So here in singly linked list, if you are taking the node, means it will be containing only uh, one data field, and another one is the address field. In terms of doubly linked list, okay, I will share you with the whiteboard. Okay, so first in singly linked list, we will be having two field, right? One is data field, and another one is our next field. Just a minute. Okay, this is singly linked list. Okay, so one is contains a data, and another one is contains a address field. We are telling that like a next field, right? So while creation of the singly linked list node, if I'm just having element 10, it is having the address 1000. Okay, another node, okay, it is having the value 20, and for example, it is having the address 2000. So what happens? This node should be connected with this node. So this address I'll be placing here. Okay, so only if I'm just telling this P, and this is as a new node, means we are telling P of next equal to new node. Okay, so if I'm just putting this line, what happens? This node address will be placed over here, and this will be what? Connected. Okay, and then another new node, again I'm just I'm just creating, okay, with the value 30 I'm having, and this node address is 3000. Okay, now this will be new node, and P equal to, I'll be adding one line, P equal to P of next. So P equal to P of next means it will be moving to this point. Then this will become what? P. This will become P. Okay. So here again, P of next equal to new node means this node address will come here, and this will be what? Link. Lastly, it is coming to the end of the list, means this node address will be what? Null. Okay, so this is about SLN. But similar thing for doubly linked list. Okay, similar thing for doubly linked list, where additionally another node, one is to store the previous node address field, another one is data, and next field address. So totally three field. Okay, so here what modification? So here previously I don't have any node, so it will be null. And here another previous node will be added, right? So what is the previous of this node? This node. What is the address of this node? 1000. So that will, I'm just putting here. If I'm putting like this, it will be connected like this. As I'm having 2000, it will be connected like this. So two-way communication is possible using this doubly linked list. Similar thing for here. Okay, this is actually null. So here in previous, what address I'm having 2000. So actually, as I'm putting like this will be connected like this. As I'm having 3000 over here, this will be connected like this. Okay. So if I want to search the element in doubly linked list also, I can search in both the direction. As I'm having two-way bidirectional. Doubly linked list is bidirectional. What about the circular linked list? Okay, what about the circular linked list in the sense? Okay, each node where it will be pointing to the next node. It will be what now? Not this part. Just a minute. Not this. Sorry. So if I'm having the nodes like this, the values 10, 20, 30, and this one 40. And we having the address 1000 here, 2000 here, 3000 here. So here I'll be putting 1000 and here 2000 and here 3000 and here nothing. So like this it will be connected. Okay, and this address is what na 4000. Then it is circular linked list na. This 4000 value will be present here. Okay, so this is circular singly linked list. So last node address, which will be the first node address. So like this, it will be connected. This is about circular singly linked list. Okay. Next one, I'm going to demonstrate circular doubly linked list. Circular doubly linked list. So in that, I'm having certain set of nodes where it contains three field. Okay. So data field 1, 2, 3, I'm having the element. So address, this one is 1000, this one is 2000, this one is 3000. Okay. So what happens here? So next field address na this 2000. As I'm putting 2000, it will be connected like this. Here this node address is 1000. I'll be putting here 1000. Okay. So this will be connected like this. Okay. Next again 2000. Here third node address will be what? 2000. So it will be connected like this. And this third node address 3000. So second node in the next field, I'm just putting 3000. So it will be connected like this. Next, it is circular doubly. Doubly linked list, it will be empty address, no address, and here also empty. But circular doubly here, so this first node 1000 will be the next field. So this will be connected like this. And again, this 3000 will be this previous node address. So it will be connected like this. Okay. So this is about circular doubly linked list. So far we have saw singly linked list, doubly linked list, Okay, and then circular singly linked list, and then circular doubly linked list. So these are the operations. These are the types of linked list we saw in today's class. Okay. So in gate questions, they can ask they can ask based on the complexity, or they can ask by giving a certain coding part, and they'll be asking you which part is missing. Okay, which coding part is missing. Okay, so like that they'll be asking. So you need to be prepared for this question based on this. Okay. So with this, we will wind up. Thank you, students.